Hello guys, welcome to my YouTube channel. Today we are going to discuss another Leetcode problem, that is merge two sorted lists. This is very standard linked list problem. This come under easy difficulty. Let's read the problem first. You are given a head of two sorted linked list, list 1 and list 2. Merge the two lists in one sorted list. The list should made up by splicing together the node of the first two lists. Return the head of the merge linked list. So basically what question is saying, we are given a two sorted linked list, that is sorted in non-decreasing order, right? And we have to return a single linked list after merging these two lists, that is also sorted in non-decreasing order. Let's see the example. We have first linked list like 1 2 4. Second one is 1 3 4. Both are sorted, right, in non-decreasing order. We have to merge them. Merging means we have to create a new linked list that have the node of from these two linked lists, and we have to merge in a way that resultant linked list or single linked list should be a sorted order in same non-decreasing order, right? After merging, we got our result 1 1 2 3 4 and 4. So this is result non-decreasing order, sorted in non-decreasing order, and it is made up of these two sorted linked lists, right? So let's discuss how we can solve this. So first, there is a two way to solve this. First way is just traverse the linked list, compare the head of the two linked list, and whoever just after comparing create a unique or create a whole new node of that node value, and just updating and creating a new linked list based on and using that two linked list, right? What I am saying, let's discuss here. We have a 1 next to 2, next is 4, right? This is linked list 1 which have head 1 pointing to this one, right? We have another that is 1 1 3 and 4, right? We have head to here. What I am telling, we have to traverse the linked list, and while traversing compare the heads value, right? And after comparing which is one is smaller, we create a node of that smaller value, and we create a new, and we update our resultant linked list based on that. So we have this linked list. First we have to create a dummy linked list, right? Maybe its value is -1, we take as a 0. This is a dummy, right? And this dummy is our current pointer, right? So after that what we do, we traverse a linked list and compare the heads value. So we have a head 1 and head 2. We compare these two, which one is smaller? Either one, right? So what we do, we create a new node of any one of this, right? We create a 1, we update the next pointer of the current pointer, right? So we update here. Also we need to update the current pointer. Now our current pointer pointing to the new node, right? And also after that, after creating a node, whole new node, we have to update our head pointer too. So now head 1 pointing to this value 2. Again after that we compare head 1 and head 2. Now again 1 is smaller, so what we do, we create a new node with 1 value, update the next pointer, right? Also update the current pointer. Now current pointing here. Also need to update head pointer, right? Now head 1 pointing here, head 2, right? Again comparing 2 with 3, 2 is smaller. What we have to do, just update 2, create a new node of 2, update the next pointer, Also update the current pointer. Right now current pointing here with 2. Also need to update head 1 pointer. Right, again 3 with 4, 3 is smaller, create a 3 node, update the next pointer, update the current pointer. Right, again update the head 2. Right, again compare head 1 and head 2, we can take either one, so we create a 4 here. Right, update the next pointer, update current. Right, now head 1 pointing to the null, after that it is pointing to the null, and when any of the linked list head pointing to the null, what we do, we just traverse the rest of the linked list, other linked list, till it pointing to the null. So what we do, we just traverse the head 2 till it pointing to the null. Right, so it currently head 2 pointing to the 4, create a 4, update its next value, update the current value. Right, now head 2 also pointing to the null. When head 1 and head 2 both pointing to the null, it's mean we completely traverse the whole both the linked list. So after that we just need to return a head of the newly linked list. So this is our linked list, but our head pointing to this one, but this is not a correct. We need to return a dummy.next, because this is the real linked list which containing the value of these two linked lists. So we have to return dummy.next. Right, dummy.next. Right, so this is the first solution. Let's discuss the time complexity of this. So time complexity, if you see, this is order of n1 plus n2. Right, because we traverse the both the linked list completely, and if we see the space complexity, this is again order of n1 plus n2, because we creating a new linked list, new node of the linked list in a separate memory. So it takes some memory. So what memory, total memory it should take, what is the time complexity, because we are creating the whole n plus 1 node. So the time complexity is order of n plus 1. Right, so this is the first algorithm, and this is the time complexity of this. So let's discuss how we can improve this. Right, the time complexity is same because we have to traverse the whole linked list, but our space complexity is order of 1, because we have don't need to create a new linked list. We just update the next pointer of our this given two linked list. Right, let's discuss it. So just create a new, again same problem, we take the same problem 1 2 and 4, I guess 1 2 and 4. Right, again we have a 1 3 and 4, head 1 pointing here, head 2 pointing here. Right, so idea is same, we have to traverse the linked list, compare the value of head 1 and head 2. Whenever we see the lower value among them, we update the next pointer. Right, next pointer. So we have to, this problem said that we have to create a new linked list in place, means we don't need to create a new node of each link. We are just updating the existing linked list by alternating or modifying the next pointer. Right, so let's discuss that and try run it. So again we create a dummy node with value 0. We have a dummy. Right, we call it as a current, our current pointer point to this dummy node. Again traverse the linked list, compare the node. So our head pointing the first node. Right, compare the value, head 1 and head 2. We have a 1 1, so we can take either one. So we take the head one, right? Whenever we see the lower one, what we do, we update the next pointer of the current pointer. So we update the next to this one, right? After that, we update the next pointer, head 1 pointer. Now head 1 pointing to this one, right? After, we also need to update the current pointer. Now current pointing to this one, right? Now again compare head 1 and head 2. We have a head 2 is smaller, so what we have to do, update the next pointer of the current pointer. So current pointer is pointing to this one, we have to update those. So current dot next pointing to this head 1. So we have here, so whenever we update the next pointer of the current, so we just updating or modifying the next pointer. Earlier this current pointer pointing to 2, so after updating, now this link is disconnected, right? We are updating its next pointer, so now it is pointing to here. Again need to update the head 2, right? Again compare head 1 and head 2. So we have to also update the current pointer. Now current pointing here, right? Compare head 1 and head 2. So head 2 is smaller. What we have to do, we have to update the next pointer of the current, right? And also we disconnect this, right? Also after that, the current pointing its next, that is here, current. Also what it the head 1 pointing its next pointer, that is 4, right? Again compare head 1 and head 2. This time head 2 is smaller. Again update the next point of the current. So we update this. This is disconnected. Head 2 is updated. Current is updated, right? Again update head 1 and head 2, right? So head 1, we can take head 1, right? So after that, this pointing to this, current pointing to this one, right? And head 1 pointing to null, right? And also this is updated. Now head 1, whenever any of the linked list, right, any of the head, so this is head 1, sorry, this is head 1. If any of the node or head is pointing to the null, what we do, we just update the current dot next to the remaining part of the next linked list, because if we update the next pointer of the current to the remaining part of the other linked list which is already sorted, so our answer will ultimately be sorted, right? For example, we have 4, 5 and 6, right? So we don't need to update head 1 after head 1 after head 2, right? So what we do, this is null, the current dot next is equal to head 2, right? If we update this, after that our list is sorted, so our resulting linked list is ultimately be sorted, right? So this is a solution of the second algorithm, right? So after updating, what will the means, if we have to rearrange this, so we have a 0 here, 1, right? Next is 1, 1 next is 2, 2 next to 3, 3 next to 4, right? 4 next to 4, also 4 next to 5, and 5 next to 6, right? So if you see the resultant array linked, not array, means resultant linked list is sorted. So what we have to return? Again the same way, our head pointer pointing to this dummy node, but we don't need to return this head. What we have to return? We have to return from here. So what is here? So this is dummy dot next, right? So we have to return dummy dot next from here. So this will be the answer. This is the head pointer of the resultant sorted merge linked list, right? So now let's discuss about the time complexity of this. Time complexity is again order of n1 plus order of n2, because we are iterating both the linked list, right? So n1 is the size of first linked list, n2 is the size of second linked list, and here the time complexity is order of 1, right? Because we are not creating any extra space, right? So this is a solution of the this is a second algorithm, right? So let's discuss, let's jump into the coding part. So right, so this is a method we need to update or create. Write the method inside this. We have a link node merge two linked list, right? We have a first linked list, head of the first linked list, and we have a head of the second linked list. So if you see the algorithm, we first need to create a dummy node. Just create a link node is equal to, we just create a dummy equal to node list node. Let's check, we create the value with 0, right? So after that what we have to do, we have to create a current pointer which pointing to this dummy node, right? After that what we do, we just iterate that, right? And iterate till any of the node is pointing to the null, right? So L1 not is equal to null and L2 not is equal to null, right? And what after that what we do, we compare the value of both the node, head node. So if L1 dot while is less than L2 dot while, right? So this one is less. So what we do, we do current dot next is equal to L1, because L1 is less. After that we update L1 to its next pointer, right? If L1 is not less than L2, means L2 is either equal or less than, right? So what we do, again current dot next is equal to L2 this time, and L2 now pointing to its next pointer. And in the both the condition, we need to update the current pointer, right? We are updating the current pointer. Its current is equal to current dot next, right? So we reach here, means any of the node is pointing to the null. We left this condition, right? We need to update of pointing to the rest of the linked list of the other linked list, that means other remaining part of the linked list. So what we have to do, if L1 not is equal to null, means L1 is not pointing to the null, what we have to do, we just current dot next is equal to L1, right? Again same, if L2 not is equal to null, current dot next is equal to L2, right? And at the end what we have to do, dummy dot next, we have to return dummy dot next, right? Let's try the code. Hopefully we have a dummy, we create current pointer if L1 not is equal to null and L2 not, right? Hope, let's run it. Error error font cycle in a linked list. Okay, how it is possible while L1 not is equal to null and N2 not is equal to, we have L1 is equal, okay, sorry, yeah, I have done here wrong, means L1 is equal to L1 dot next. Right, so this is accepted. Let's submit our code. Guys, it is accepted, so it takes 1 millisecond and it is faster than the 73% of the Java code solution, right? So this is the solution. Hope you like it. If you like it, please hit the like button and subscribe button, and thank you for watching the solution.